All right, so we are skipping 5 sections. We're going to kind of go backwards after and go back to like section 4.9. But right now we're going to look at section 4.11, simplifying and graphing complex numbers, okay? Complex numbers in standard form look like this, a plus or minus bi. And actually, a could be a positive or a negative as well. Some people like to put plus or minus a, plus or minus bi. But it's a plus or a minus bi, okay? This is called the complex number. The I is an imaginary unit, so let me put that right here. This is called the imaginary unit. So if you've ever heard of imaginary numbers, well, that's where they come from. Okay. So imaginary units, they can actually have actual values, but you guys have heard before, you can't take a square root of a negative number, right? Like if I were to tell you what's the square root of -2, we'd say, well, you can't find that answer, right? Well, it's actually not true. The square root of -2 does have an answer. It's a radical or square root of 2i. But the square root, the negative value inside of a square root has a value. So the square root of -1 is what we call I. Okay, so anytime you guys see the square root of -1, that's going to be I. And we can write -1 as I squared. So make sure you write those down because those are going to pop up a lot in our work. Okay, so if you write the term I, that basically means the square root of -1. Okay, and if you write the term I squared, you can rewrite it as -1. Okay, so anytime you see an I squared, you can replace it with the -1. That's going to be one of our main points here. Now, there's one other thing I want you guys to note is that the term a plus or minus bi, we can rewrite it as a point, a comma b, which is supposed to be identical to x comma y. So in other words, your a is like your x value and your b is like your y value. Okay, they're going to ask us later on to graph these things, right? Graph this complex number. So we're going to want to rewrite it as a point. And then once we rewrite it as a point, we're going to basically say, oh, well, this point is basically xy. All right. So our a comma b comes from that complex number. Okay. And it's basically just xy. Okay. So complex numbers are given to us. We're going to treat them very much like terms. You're going to see us kind of do that right now. Anything with the term I can be added or subtracted with any other term that has an I in it. And then any normal number, like the term a, like a 5, a -3, you can add them with other numbers as well. So a lot of this is just basically like terms. Okay, so let's go ahead and do some examples so you guys can see how this stuff looks. So we're just going to be simplifying. Okay, I think we have A through E. We're just going to be simplifying lots of different ways. Okay, because when you guys get your homework, there's a lot of different problems they're going to be throwing at you. So I'm trying to show you a little bit of each. So we're going to simplify, let's say part A, 2i times -6i. Now remember, treat the I like any other letter, like an x, right? If you had x times x, you would write x squared, right? X times x would just be x squared. So for part A, 2i times -6i, well, 2 times -6, that's -12. And then I times I, that's I squared. But what can I replace I squared with? I wrote it just right now. Look on the very top part of your notes. -1, right? So this is -12 times -1. Okay? So -12 times -1, that's equal to a +12, and you're done. Okay? So that's it. That one's done. All right, so -12i squared, that's what we get when we multiply them. And then I get -12 times -1, and I multiply those, so that's going to be a 12. And that's all you have to do for that. I mean, and yeah, they can get more complicated, but let's just notice that that's not that hard to do. But do remember, I squared is -1. Okay? Now, part B says 3i plus a -8i. So that's basically 3i minus 8i. Okay? Well, treat this like if it was 3x minus 8x. So if it was an x, you would just subtract these, right? So with an I, do the same thing. 3 minus 8, that's negative 5i. And that's it. You don't have to do anything else. Okay? We're just treating them like terms. So nothing too difficult. You're just adding and subtracting them, maybe multiplying them. Okay? So hopefully right now you're like, okay, this isn't that terrible. Okay, it's not like it gets that much more terrible, but. All right, now 4i quantity squared. Okay, now for part C, 4i quantity squared. The square means to rewrite it twice. Okay, or you could just distribute the power of 2 since it's a product on the inside, but sometimes people get confused with that. So I'm just going to rewrite it 2 times. Okay, so it's going to be 4i times 4i. All right, so 4 times 4, that's 16. And I times I, that's I squared. But I squared is negative 1. So this is 16 times negative 1. So that's negative 16. And that's it. You're done.
So just whenever you get a I squared, that's when you put negative 1?
Yeah, whenever you see an I squared, you're going to change it to a negative 1 and then continue to multiply through. Okay? Like I said, it's not that this is hard stuff. It's just different, right? But you're kind of used to it with normal letters. Just that before, when you got like a y squared, you didn't write like a 2, right? Here, an I squared is a negative 1. So, all right, part D, we're just going to do what we normally do, distribute. So I'm going to multiply 3 times 6 and 3 times 2i. So 3 times 6, that's 18. 3 times 2i, that's positive 6i. Okay, let me move this down just a bit. Right there. And then I'm going to multiply negative I times 6 and negative I times 2i. So negative I times 6, that's negative 6i. Okay? And then negative I times 2i, that's negative 2i squared. All right, well, the 18, I'm just going to rewrite it. What's 6i minus 6i? That's 0, right? So these are going to cancel. So notice they behave just like normal variables. And then I have minus a 2, but I squared. So that'd be negative 1 multiplied by negative 1. Right? So I squared is negative 1. Well, negative 2 times a negative 1, that's a positive 2. So that's 18 plus 2. And 18 plus 2 gives you 20. Okay, so again, we're just simplifying. That's all we're doing. We're multiplying stuff out. We're simplifying it. I noticed I had a negative 2i squared. So I know I squared is negative 1. So on the next line, I wrote it as a negative 1. And then I just multiplied negative 2 times negative 1. Remember, your order of operation says multiply before you subtract, right? So don't do 18 minus 2. Don't do that. It's negative 2 times negative 1. So that's a positive 2. And then you add. So what do you guys think? I mean, not too bad, right? It's nothing crazy difficult. It's just basically we started with this in the beginning of the year. These were like the first lessons we did, adding and subtracting like terms. Just that right now we're giving a different letter a new meaning. The i's are imaginary values. So I think this is the last one, and then we're going to do some graphing and stuff. Okay? And the graphing is pretty easy too. It's not hard to do. But I think this is the last one from these. Let me really quick double check. Oh no, there's one more after that. I thought we went to E, but it's that. No, it's not that this one is more difficult. It's just a lot more things. That's all. But you do have to be careful because since everything is inside of a parenthesis, the sign in the middle is going to distribute, right? So this negative is going to distribute in there, and this positive is going to distribute in there. Remember, the positives don't change anything, but the negatives do. Okay? So I'm going to rewrite this. This is basically negative 4 plus 6i minus 3 minus 3i plus 3 minus 4i. Remember, the negative changes everything inside of the parenthesis that follows it. The positive doesn't change anything at all. Now let's just combine like terms. So my like terms, I'll kind of highlight them here. Negative 4, negative 3, positive 3. And then my other like terms will be a positive 6i, a negative 3i, and a negative 4i. Those are my like terms. So let's do the yellow ones first, because if you're wondering why am I going to do the yellow ones first, don't we normally use the variables first, right? Like we always put the x's first and the numbers towards the end. Well, it's because the format of these complex numbers has the number in the front, the imaginary unit in the back. Okay, so the I term should always be towards the back. All right, so negative 4 minus 3, that's negative 7, plus 3, that's negative 4. And then 6i minus 3i, well, that's 3i, minus 4i, that's negative I. Negative 1i or negative I. Now, I don't change that I into a negative 1 because it's not I squared. Okay, I'm just going to leave it like that. This is my answer for that one. And I was wrong. There is an F portion to this. And then we do the graphing. The graphing is usually very simple as long as you understand that a complex number and a normal coordinate value, so the a, b, and the x, y are the same thing. If you understand that, then you're fine. So 2 minus I quantity squared. So again, anytime you have something in a parenthesis and it's squared, you can rewrite it twice. So this is basically like saying 2 minus I times 2 minus I. Same thing. And then we're going to distribute just like we did earlier. So let's do that. We're going to do 2 times 2 and 2 times negative I. So 2 times 2, that's 4. 2 times negative I, that's negative 2I. And then we're going to distribute the other part here, negative I times 2 and negative I times negative 1. So negative I times 2 is a negative 2I. And a negative I times a negative I is a positive I squared. Now there's that I squared that we saw earlier, right? So take note of that. So this is going to be a 4. Negative 2I minus 2I is negative 4I, not 0. Negative 4I. And then plus, what's I squared again? Negative 1, right? So that's actually a minus 1, right? So plus a negative 1. So let me rewrite it. That's going to be 4 minus 4I minus 1. And 4 minus 1 is 3. So we have 3 minus 4I. And this is your complex answer. Now just jumping ahead really quick. If I ask you to write this as a point, remember I showed you, let me go all the way up really quick. I showed you at the very beginning that a plus or minus bi, you can rewrite it as a comma b as a point, which basically translates to x comma y, right? So if I ask you to write this answer as a point, you should say that that's 3 comma negative 4. Okay, I'm just kind of giving you a sneak peek into what we're about to do right now. Okay, so it's easy to write complex numbers as points and vice versa. If they tell you this point is a complex number, you can rewrite it as a complex number. You can go back and forth. Okay, these are the same thing either way. All right, so anyway, let's go to the graphing part just to show you. So I'm going to pause this so you guys can write this down. All right, so I know while this was paused, I explained it, but remember, complex numbers can become normal points. Just take the signs on the a and the b terms, keep them with them, right? So 2 minus 3i becomes 2 comma negative 3, all right? A negative 5 plus 1i becomes a negative 5 comma 1, and a negative 3 plus 4i becomes a negative 3 comma 4. It also works backwards, so we're going to do a little bit of each, okay? But it works backwards where you can take a point and rewrite it as a complex number, and we will do that. So let me show you example number 2. And I'll pause this so you guys can write it down. All right, so one thing you guys should notice for example number 2, as I kind of mentioned off recording here, is the axis, okay? So we have an imaginary axis. You don't normally write it, but I'm just going to write it for us right now. We have an imaginary axis and a real axis, okay? The real axis is basically your x-axis. The imaginary axis is your y-axis, okay? All you have to do to graph these things is change the complex number into a point. That's it. So what would be the point representation for 2 plus I? 2, 1, right? So I'm just going to go to 2, 1, and I'm going to put a dot there. So 2, 1 is right here. I'm going to put the A right there because that represents my A example. What's the point representation for B? All right, -3, -4. So I'm going to go to -3, -4. I'm going to put a dot right there. I'll put B, and that's it. That's pretty easy, right? I mean, just rewrite it as a point, graph it. We know how to graph. We've been doing this for years, right? So simple. Example 3 is going to be just backwards. I'm going to give you a bunch of points, and then you're going to give me the complex number, okay? But I would recommend when we do that, you write the point first, and then you write the complex number. So here we go. Example 3. Let me give you a little bit of time to write this out. All right, so for example 3, we have to write the complex number that's graphed. So I've graphed 4 of them. You can see I labeled them A, B, C, and D. And on the right side, I have A, B, C, D right there, so we can put our answers there. What is the point for A? 2. Okay, -4, 2. So -4, 2. Actually, let me get rid of it right here. I don't have to put it there. -4, 2 becomes -4 plus 2i. This is my complex number. Okay. What's my point for B? -5, 3 for B is not correct. 2, -5. So it's backward. It's 2, -5. Right? Because remember, the horizontal goes first, and the vertical goes second. So 2, -5. So this becomes +2 minus 5i. All right, so the last two are kind of tricky, but not hard to do. What is the point for C? 4, 0. All right. So I'm going to write 4 plus 0i. But if there's a 0 next to I, that means it's not there, right? Because 0 times I is 0. So this is just basically 4. So 4 plus 0i is not that it's wrong, it's just not simplified. Okay? And what about part D? That'd be 0, 5. Yeah, so 0, comma 5, which is 0 plus 5i, or just 5i. So sometimes the imaginary part is missing, so the I term, like part C, the imaginary part's missing. Sometimes the real part is missing, the A value, okay? That's your real value. So sometimes if it's A 0, then it's okay. It's not there. Just write your imaginary part, and that's it. Okay? And this is what your homework is going to be like. Some graphing, forward and backwards, right? Graph the point, or write the complex number. And then it's just simplifying a lot of stuff. So let me go ahead and stop this and give you guys your homework.